Morning greeters, back again with our info session. Today we are proudly presenting the University of Nottingham Ningbo, China, and what we call it UNNC. We are happy and delighted to have Professor Kwong as the Associate Professor in Electrical and Electronic Engineering, and also the head of the Department of Electrical and Electronic Engineering at UNNC. And also Mr. Patrick Ma as the UNNC Regional Manager of International Students Recruitment. In today's info session, we will be focusing on the Faculty of Science and Engineering, and Professor Kwong will bring the presentation to us. Please welcome Professor Kwong and Mr. Patrick Ma.
Thank you, Joko. Welcome, greeters.
Morning, Professor. Morning, Patrick.
Morning.
Morning. Just nice. The bell of Nottingham is ringing.
Right.
Yeah.
Okay, so shall I begin?
Yes, please, Professor.
Okay, thank you. Thank you, Pak Joko. Thank you to my colleague, Mr. Patrick Ma. My name is Dr. C.F. Kwong. I am a Malaysian by nationality, but I've been working here at University of Nottingham Ningbo, China for about 7 years. I'm currently the head of department for electrical and electronic engineering. So what I'm going to share with you today is a little bit about the university, just a little bit, and also a little bit about the faculty, just a quick one. And we will focus more on the programs that what we have, the academic programs that we have, in order for you to understand how, if you have an interest to study in China, particular, how we make it so different as compared to other institutions. So to begin with, the University of Nottingham is one of the top university in the UK. In fact, it's one of the top in the world. It's what we call a public research university. It's a very research intense university. In other words, if we say that we are research intense, we are the one who create knowledge. We don't transfer knowledge. We not only transfer knowledge to you, we create knowledge and we transfer the knowledge to you. So that is only can be done through research. And in the year 2000, we have another campus. We opened one campus in Malaysia in the year 2000, and then in China, we opened a campus. That's what we call the UNNC, University of Nottingham Ningbo, China, in 2004. We are the first Sino-foreign university in China. And if you compare with a lot of other similar arrangement, we are the only university that is maintaining the same brandings, the same name, everything the same, and the whole campus itself in China. So just a quick one, we have about 7,500 students from all over about 75 countries. In the whole Nottingham itself, we got about 30,000 students, mainly focused in the UK. Most of our staff are recruited from top universities in the world. Even some of my colleagues are from Cambridge, Oxford's. Even I know one of them are from MIT. So we are from the top universities and come here to deliver top research and education to the student as well. And contrary to a lot of people, when people ask me a lot, they say that, oh, yeah, Nottingham in China, so the course you teach in English or in Chinese? Of course, this is a British university. We conduct everything in English, and it is a UK style education. We also have program types like what we call a 2+2. 2+2 means that you do 2 years here at UNNC and 2 years you transfer into the UK, or if you prefer, you can go to Malaysia if you want to. We also have what we call a 4+0, which means that you complete the whole degree here, 4 years here at UNNC itself. And a lot of people also ask me the same thing. You say that the certificate, is it from China or Malaysia or things like that? The answer is very simple. The certificate is from the UK, directly from the UK itself. So you'll be receiving the same certificate as the one in the UK because it is validated, and quality control of the education is actually is controlled in the UK. Even when we start recruiting academic staff to teach and to do research here at the university, one of the panel member has to be from the UK itself, just to confirm that the standards that the staff that we recruit is the same as the one in the UK. So so we have global partners. Global partners means that this one is that if you come here to study, and let's say after 1 year you study, the second year you want to do an exchange program. Exchange means that you go to another university, spend 1 semester or 2 semesters in another university, and then when you come back to UNNC to complete your degree, then the time that you study in other university is recognized, and you can have what we call like a credit transfer to us. So with that, then you can have a new experience, so probably study in US or in Canada as well, or even in Europe or in the UK. So we have a lot of global partners that we develop over 10 years. So a lot of our students, actually, in fact, 80 or 90% of our students continue to study their overseas studies. And what you see here is pretty much from the Faculty of Science and Engineering. Most of our students actually go to the in fact, they actually go to UCL and Imperial College. And in fact, some of my students here went to Cambridge University, and so far I think 2 or 3 of our students went to MIT in the US to complete their study in their postgraduate. So yes, teaching and learning, you don't have to worry. It is definitely what we call audited by the what we call the quality agent QAA, Quality Assurance Agency, which is the agency that governs the teaching and learning quality in the UK. So the last review was 2013. The next review coming, I think, is this year. So, but we have full confidence that we can pass as the same as the one in the UK. So the university has 3 academic faculties. So we are here, Faculty of Science and Engineering. With these are all the schools and departments that we have. So I can just do a very quick introduction on the faculty. So the faculty established in 2009. We are relatively new. I don't say we are really new. We are relatively new. And even we are just new, and then just take an example. Even though we are new, even my own department, we got last year alone, we are awarded by the government and the industry for the research grant of 10 million renminbi. So 10 million renminbi, that's a lot of money. It's about I think about $600,000 US to do a research, just for research. Okay, so that actually shows that how the government and the industry recognize our expertise. So that alone translate to the quality of the teaching and the department, the staffing in the department as well. So the Faculty of Science and Engineering has 2 different major disciplines. One is science, another one is engineering. So in the engineering itself, we have about 6 departments. AAE, we call it architecture and architecture environmental engineering. So this one is basically if you want to become an architecture or you want to become the building engineer, so you study in this department. Then we have chemical and environmental engineering, including if you want to learn chemistry as well. Civil engineering, electrical, electronic engineering, mechanical, materials and manufacturing engineering. And under them also they have what we call a school of aerospace, where you learn how to build aircraft. In science, we have 3 schools, School of Computer Science, Geographical Science, and Mathematical Science as well. So all programs are internationally accredited in the faculty. These are all these are the professional institutions in the UK, and they are internationally linked. So, for instance, if you want to study electrical electronic engineering, we are accredited by the Institution of Engineering and Technology. For mechanical engineering, they are accredited by the Institution of Mechanical Engineers. Even for the architectural engineering, architecture, they are accredited by RIBA. For civil, they are accredited by what we call a JBM, Joint Board of Moderators. There are 4 institutions under them, one of which is the ICE, definitely, Institution of Civil Engineer. So there's a lot of engineering courses that we have is accredited. Now, what does mean by accredited? So accredited means that we have an independent body from the industry. They come to our course and then they look into the quality of our course, the curriculum, the content, the staff quality, the facilities, the labs, the management of the department. So they look at all this and then they say that, okay, it fits to the standards that we think that is appropriate at the industrial level. Yes, then we accredited. We give you a form of recognition. All right. So accreditation is very important to us. So these are the academic programs that we have, but I will just leave this very quickly because I will we'll talk about this a little bit more detail much later. These are our chair professors. Chair professors means that they are higher than professor. All right, professor is already higher. Chair professor is even higher. We got about 14 leaders and chair professors, and these are the what we call the world top scientists and engineers that work with us, mainly focus on research. And later on, they will also involve in teaching as well. So you got the opportunity to meet all these world-leading professors who are very, very good in their field, and you can talk to them. In fact, in the summer, if you want to, if you don't want to go back to Indonesia, you just want to spend some time here in summer at UNNC. So what we have is that we have a summer research internship. You can probably work with one of us, or with the professors, with the chair professors over here to participate in their research. That will give you a different dimension rather than just study in the classroom. Then you can see what are the cutting edge of the research that they are currently doing. So I'll just probably, these are the statistics. These are where our graduates go. Top 100 QS ranking in the world, over 86.2% of our graduate went to the top 100 university in the world to further their studies in master's degree, which is the postgraduate. So these are the most popular university or the destination of our graduate going. Research group, I'm not going to talk too much about the research group, just quickly pick one or two that that we are really good in. Artificial intelligence is what we are really good. For in fact, like power electronics, machine and controls research group, also that where we are really good in. Like for instance, why I picked this group also because their research is very cutting edge, where they built the future engine for the aircraft using electricity. So in the future, we don't use gasoline anymore for the aircraft. We use electricity to power the aircraft. So these are the cutting edge research that we have. Okay, so I'll just have a quick one. So key disciplines, these are the list of the key disciplines that we have. So what does key discipline means? It means that the Chinese government actually have what we call like an award to say that, okay, this discipline, whether electrical, electronic, mechanical engineering, etc., we award them because we recognize that the quality of the department or the course that they are running very good, and it fits to the Chinese standards, which is very, very high, to be honest with you. And because of that, and then most of the Chinese students, when they look at this, they said that, oh, okay, you have a key discipline, and it was recognized by the Chinese government that you are the top discipline. Yes, I think that we recognize that you have a very good quality, not only in teaching, but also in research. We also have a key laboratories and a research platform. So it's the same thing. Key laboratories is where the Chinese government invests money into the university to do research with a key, in a certain area. Like I mentioned to you just now, one of the research group that actually do electric engine for the aircraft. So this is one of the examples of the key laboratory. We call it the key laboratory on the more electric aircraft technology. So in the future, who knows that we don't use gasoline anymore to fly the aircraft. We use electricity. We have composite groups. This one also, this group is quite interesting. They work a lot with GE, General Electric, to build the materials for the aircraft. As well as they also work with Boeing and Airbus to build the composite material for the aircraft, where the aircraft in the future perhaps is not metal anymore, it's not aluminum or alloy. They use a composite material, so it's very, very light. So this is another cutting edge research that we have. Of course, with this, we also translate that, we also teach you when you're here in our classes. This one is the same thing. This one is this one is transportation. This one new energy. If we talk about new batteries, I'm sorry, we'll talk about new electric aircraft and electric cars. You have to talk about batteries. So the batteries, you know, today the batteries is not as efficient as what we hope for. Even it is Tesla, there's a lot of research going on in Tesla to focus a lot on how the endurance of the battery and how the battery will affect the environment itself. Now, the second thing is, we also concerned about the what we call a carbon neutral research. So the carbon neutral research is more on the global or climate change. If you heard about the Paris Accord, where a lot of governments signed the Paris Accord, and they hopefully to reduce what we call greenhouse gas by the year 2050, so the world will be not as hot as now. So they do a lot of research, you know, what kind of methods that we can do, and they probably advising the government how we want to reduce the carbon emission on this one. So there's another one. This one is electronics, materials and devices. Where we do is that we miniaturize as much as possible the semiconductors, so that in the future your chip can be even smaller and smaller and smaller and smaller. When the chip becomes smaller and smaller and smaller, then you can pack on more chips, more transistors inside there, and it become more powerful in terms of computational power. It become more power and faster. So that is one of the research that we are doing. So I'm not going to talk too much about Ningbo. I'm sure that Pak Joko has another video to talk about Ningbo itself, right? So and as well as the facilities and what we do in the university itself. So so what we have here is that this is our electronic brochures. I'm sure that Patrick can share to Pak Joko later. And if you want a copy, you can ask from Pak Joko. And then, so what we have here is, this is the overall, the whole overall, what we call overall story of the faculty itself. And then, if you see here on the lower right, you can see the YouTube. You can always use this one as scan and watch the video. Maybe people say that, you know, if you in what we call in bahasa Malaysia, we say that kalau tak kenal maka tak cinta. So so if you don't know, you don't fall in love, right? So one of the way that we make you fall in love is through the video. Then you can know, you can see our professors talk about the research, our professors, they talk about the classes, how they teach the class, what are so unique about our classes and our courses, right? So just a quick one. So I was just start very quickly on the architecture, environmental engineering. So architecture, environmental engineering, this one is basically is a building engineer. So what is the meaning by building engineer? It's about built environment. Give you a good example. So one good example is that if you build a building, the building itself, right? It has to become live. Live means that inside the building, the environment must be maintained. In a hot place like in Malaysia or even in Indonesia, you cannot have a building without air condition, right? And then air condition, you need to design it properly so that it is very energy efficient, as well as it is very comfortable for us, and yet at the same time you don't waste a lot of electricity, things like this, right? So these are the people who are very specialized in this area. They're talking about the environmental inside the building, and sometimes they also do the building without air condition in a hot country. And how do you maintain the regulate the air, you know, the flow within the building? So these people are very good in designing the building in such a way that, you know, the environment inside the building is bearable for us to live. Or even a cold country, like say in Beijing itself, it's very cold. And then or even in Heilongjiang province, right? It's so cold. So how the heck that we can design a building so that it stay warm during in the middle of snowing, right? So these are the people. This is what they do, right? They have what we call a 2+2 and 4+0. If you remember, 2+2 is 2 years here and 2 years in UK. 4+0 is 4 years here in China itself. The next one is what we call architecture. Architecture is very simple. You become a designer as well as the same time become an artist. So you become a building artist. All right. So if you been to Singapore before? If you go to Singapore, you know, you see there's a one building with 3 pillars and one like this. What they call it? Marina Bay.
Marina Bay Sands.
Yeah. Marina Bay Sands, right?
Right.
So you were wondering, you know, how the heck that they have 3 pillars and one like this, you know, hanging like this and still very safe. Okay, so this is the architecture. They work together with the civil engineer. They design in such a way that in the building that they put like this, right, it's still safe. See, you design, it looks aesthetically very nice, but at the same time, it's safe. They use science and engineering in order to make sure that the design is sound, that it won't crash down. There is a joke that they say that, you know, if you know the frequency of the building, they encourage people don't dance Macarena, you know, on this part, because everybody jump at the same time, and then when they jump and then you follow the frequency of the building, it become so large and then it will collapse, right? But anyway, there is it's just probably a pastime joke, but in terms of scientifically, it sounds right. But so this is what these people are doing. So they are doing, they are artists. They design to make it looks nice, and then they have the they need to put in the creative element inside there. Also, they also need to learn about the historical architecture design. Give you a good example. Let's say in Jakarta, there's one area, say for instance, everything is about cultural, right? So the building design must be cultural. So they will do some research. What are the cultural, probably Javanese culture or Sumatra or Balinese culture. And then the tune that they design to in such a way that is very Balinese or very Javanese, you know. So, and then what they do, this one, they need to do a lot of research, and then they put it into their building design. So this is what they learn over here, okay? And they have studios to do they build small houses, you know, to actually simulate their design as well. So this is architecture, right? If you see over here, it means that it's accredited by this specific institution, professional institution. These are the industrial accredited. Again, you can see over here, there's a YouTube. Please feel free to use a QR code use a phone or what, to scan the QR code, and you can go to the YouTube. You can learn more, and the professor will talk more about their courses. Now, chemical engineering is very interesting. What they do is that the chemical engineers, they are chemist and a chemical engineer. So this course, this department, they offer chemistry as well as chemical engineering and environmental engineering. I will talk about environmental engineering later, but the chemical engineering is that they are responsible to convert all the raw chemicals into products. All right, they convert all the raw materials into products. For instance, the raw materials is, say, kelapa sawit, the palm oil, all right? And then you want to make a soap, all right, sabun, all right, a soap. So what they do is that they will extract a certain chemical through a certain process, and then they will actually convert it to become a soap. And then once they do this, and then they need to think about how they mass produce this. All right, so mass production is not that simple. So the chemical engineer, they are the one who are responsible to design this mass produce. It's not only something that is not edible, it's also something to do with food and drinks as well, something that's edible. So the chemical engineers are the one who involved in this thing. So this is one good example. They also involved in oil and gas, right? Oil and gas in Indonesia, particularly, oil and gas is a very, very popular and well-paid profession. So the oil and gas, you extract the raw oil. Now, how the heck you want to separate it all to become a petrol, diesel, kerosene? So these are the chemical engineers. They are the one who are responsible to design the whole process into this. Okay. And then civil engineering is one of the oldest. All right, on the right side here, civil engineering is one of the oldest engineering ever. It's all the way to the days of the pyramid, where the Egyptian built the pyramid, and then it's about 4,000 years ago when they built big buildings, and they were thinking how the heck to move big stones, all the way to the peak. So this requires a lot of engineering design work. It's not only about the design, but it's about the feasibility, it's about the safety of the buildings. This is what they do. Now, civil engineers, they are not only do buildings, but they also doing roads, all right? So they build roads, new roads. I think you see, I think President Jokowi just announced that there will be a new capital for Indonesia in Kalimantan. I think they call it Nusantara, if I'm not mistaken.
Yes.
Yeah, so the surveyor and the civil engineer will be the busiest people at this time. Town planner, they will go there, and then they will start, when they start building, they need to build roads, they need to be building, especially roads, right, and bridges. So the civil engineer has to go there, and they need to build and develop the area. Okay, so this is what the civil engineers do. There's a lot of other things also. They involve in mining as well, right? As well as the even, in fact, water engineering. They build the dams to collect water, or even for electricity. Okay. Now, electrical electronic engineering, this is what I'm passionate about. So this, my specification, my expertise is in mobile and satellite communication. So mobile is your mobile phone. Satellite is the satellite, television communication. That's my area of expertise. So my basic degree is in electrical and electronic engineering. My PhD is in mobile and satellite communication, where I become more specialized. So in other words, what I'm trying to say is, in electrical and electronic engineering, is a very wide field. It's very, very wide. You have electrical, you're talking about all the way to, say, 240 volt, the grid, the power grid, or all the way to a small motor. It's normally very high electricity. For electronics, normally it's a very, very low voltage, maybe about 24 volt, not more than 1 ampere, or probably 2 ampere. So electronics mainly on these electronics devices, And to power these electronic devices, the people who involved in electrical will actually come in to power these devices, right? This is the simplest what I can explain. So the career prospect for electrical electronic engineering is very huge. I mean, just yesterday in Malaysia, if you follow the news, in Malaysia yesterday, there was a 2 hours blackout. All right, there was a 2 hours blackout in the southern side. The whole factory cannot move. The whole city cannot move. The whole building cannot move, become dark, you know, things like this. If you look around you, all right, you can count, you can't even count how many electricity is around you, all right? I mean, electronics products is around you. So the world is moving heavily towards the dependent on the electrical and electronics products. So this is the reason why our field is so wide. I can't even explain, say, in one go for this particular session itself. It's very wide. But if you're really interested, you can actually email to me or Prof. Patrick, so we can have a more customized discussion with you to on your career goal. But for now, we just probably just touch and go. Again, if you want to have your own time, just watch the video, please feel free to scan this QR code. Now, this one is interesting, environmental engineering. So environmental engineering is the same as chemical engineering. It's just that environmental engineering is they convert the product back to the chemical so that it, and then at the same time, it will not be harmful to the environment. So you see, chemical engineering is from chemical products, sorry, chemical raw material to products. Whereas for environmental engineering, from the products, how they want to safely change it back to the raw chemical, so and then at the same time it protects the environment. So this is something very, very interesting today. Everybody is talking about environment, you know, the world is dying, you know. So engineers like environmental engineers, they are the ones who are responsible to look into this. They're looking into waste management. They're looking into the air pollution. They're looking into environmental assessment. You know, environmental assessment is very, very interesting. So environmental assessment is that every time before they build a building or build a road or build a city, and probably in Nusantara, you know, they're building a city over there. There's a lot of environmental engineer goes inside there, do what we call environmental impact assessment, EIA. So they will want to do the impact and how it can affect the environment. And then at the same time, then they will write a report to the government, to the NGO, non-governmental organization, the Greenpeace, not Greenpeace, the organization that promotes environment, to make sure that the whole environment there is not harmed. All right. So this is what they do. Okay. So I'm moving to the next one. Mechanical engineering is very straightforward. Again, a lot of things, everything is about mechanical. The cars, the electric trains, or even the conventional trains, aircraft, aerospace. So all this mechanical. Mechanical engineering also is very broad, just like electrical and electronic. Then they have a wide range of career opportunities for you. You know, you can easily see over here, right? They are involved in energy, even manufacturing as well. Products, materials. They also learn about materials. Remember just now I mentioned to you that there's a group of researchers that actually research on the composite materials for the future aircraft, right? So in the future, we don't use alloy anymore. We use composite materials so the aircraft become lighter. So it's very straightforward, mechanical engineering. Product design and manufacture. This one is basically people who are designer. Now, people like me, we design, say, handphone. What you see over here, this handphone, okay? I like this handphone, right? This is a Samsung Fold 3. And then people like us, we design the electronics inside there, all right? But then we do not have the knowledge to say that, oh, the user prefer this dimension, then it's more comfortable to see ergonomics, right? Or the user prefer it to fold like this. The dimension is supposed to be like this. Or the user hold it like this. It's much better, okay? So these are the what we call the ergonomics, right? So in fact, I show you a special mouse. The mouse, right? This mouse is not like a normal mouse. This is called an ergonomic mouse, right? So why instead of my normal mouse, I hold like this, I hold like this. Okay, so I hold like this, so my hand won't be so tired. Okay, now who are the person who think about this? So these are the product design and manufacture people. All right, so they are the one who think about ergonomics. Aesthetical means that it looks nice. You see this phone, it looks really nice. The way how they design it, you know, it looks curved, you know, things like this. When you open it, so it still, it looks you know, in Malay we call sedap dipandang. So it's nice to see, right? It's nice to see. So if this is the case, then these are the people who are in a product design, who are to design it. And they also think about, okay, I have a product and I design it. Now, how do I want to manufacture it? Right? Manufacturing is not that straightforward. You know, there is a difference between a Rolls Royce, you know, a car, right? A Rolls Royce or a Bentley, and say a Toyota. So a Rolls Royce, you know, these are rich people who drive that car, Rolls Royce. That car, this is the very, very expensive car. They mainly, what they do is they are custom made. Custom made means they assemble using hand. All right, they assemble. But then like Toyota, they cannot assemble hand because they are producing, say, about 100 or 200,000 cars a year. One day, probably they produce 5,000 cars. Now, how the heck you want to produce 5,000 cars in just one day by using hand to manufacture? You need some sort of a robotics or a system to manufacture this. And then if you want to know more about manufacturing, you probably read about Henry Ford, F-O-R-D, right? Ford, he's the father of manufacturing, right? So if you read about him, then you understand how they transform from an economy where they use a hand to assemble to the manufacturing economy. So these are the people who are really learn how to manufacture and design the products. Okay. Then the next one is the aerospace engineering. So aerospace engineering is a more specialized field. Basically, you learn how to build aircraft. I think Indonesia has one aerospace industry. Well, I'm very sure that they are very interested to hire a lot of aerospace engineer, but the skill sets that you have does not necessarily only limited for you to build an aircraft. Okay, so the skill sets that you learn over here is allow you to go to the car manufacturing industry, for instance, where you build the body of the car, so it's very aerodynamic, for instance, right? So it can run faster, you know, things like this. So this is another good example. It's about skill sets, right? So yeah, so that's aerospace engineering. So chemistry is what I mentioned just now. Chemistry is mainly people who are extracting or separating chemical products. That's all, and probably pass all this to the chemical engineer to do a more usable products. And chemistry people in chemistry also, in terms of medicine, they are also making new medicine. But they not really invent new medicine or discharging new medicine, but they are involved in the research, all right, for the new medicine together with the pharmacist, all right, together with the pharmacist. So these are the chemist. So basically we call them a chemist. Now the other one is this course is one of the most popular courses, which is the computer science course. Again, everything is about software, right? Everything about software. Everything is about big data. You have heard a lot about Alibaba. In China, we talk about Alipay. We talk a lot about Taobao, right? The Taobao where we do a lot of e-commerce. Now, how the heck when I go to Alipay or go to Taobao, and then when I check, immediately they can know what is my preference, what kind of things that I want to buy. All right. So these are the computer scientists. They are the data analytics to look into this. And then they need a lot of other form of more specialized skills, which is, for instance, like artificial intelligence to do this. So artificial intelligence is, okay, the definition of artificial intelligence is an act of a machine to mimic human as much as possible. So that is the artificial intelligence. So it make everything become more human, become more intelligent. And then I hear a lot of people ask me, whenever I give talk about artificial intelligence, people ask me, will the robot or artificial intelligence take over the world? So my answer is that if you come here to study, you will understand very well. It will never happen. You come to here to study, we will tell you exactly how it will never happen. Because if I tell you now, it's going to be like the full lecture of the artificial intelligence already, right? So yeah, so it will definitely not happen, but. Of course, artificial intelligence is a more specialized one, but then we have a more general computer science course for you to learn. Now, this is interesting. Environmental sciences. What is the difference between?
Professor,
Yeah.
a lot of our prospective students was
Yes.
like asking if I had taking computer science or computer science with artificial intelligence, do they get like, big data or data science altogether?
In general, if you look into the computer science with artificial intelligence, yes, you will learn on the data science now, but be a little bit pragmatic when you think about this. Now, data science is a very specialized course. What you learn in computer science is very, very basic, because it's very huge. It's a very huge course discipline, computer science. Data science is not just about big data. It's a lot of algorithms and mathematics, things like that you need to involve. You need to go all the way to a master's degree in order to really specialize in this area. And if you are more interested in the research, into pushing the knowledge boundary further, then definitely you do a PhD. Yes, it is, you will learn, but then I just want to have a expectation management on you, is that you will learn, but then you will not become like a specialist. In order to do a specialist, you have to do a master's degree in data science or analytics, all right?
Okay.
Yeah. So, okay, so I continue, right?
Yes, please.
Okay, thank you. Bachelor of Science in Environmental Science is different than environmental engineering. Just like I talk about environmental engineering. So environmental science is more humanities, is more social science. They involve science. They involve a lot of lab work. They involve a lot of field work. That is very interesting. Where you go to, in fact, our students even visited the glacier in Sichuan, the glacier. So and then they will witness the glacier. Probably they take some sample on the glacier. They go back to the lab, and then they do some investigation under the microscope to see how much the glacier is disappearing, things like this. And in terms of career prospect, these people are the one who are mainly advising the government on the policy issues, on the what they call that, on the scientific level issues, on the humanities issues. In fact, even to the point of human migration, right? How the human migration can affect the environmental part of one city. In fact, one of my colleagues, who is the acting head of this school, he is doing one research on what we call a sponge city. A sponge city, not a sponge. So a sponge city is that the way how he designed the city, that when it's flooded, then how they absorb all this flood water for another use, for other use. All right. So this is what the people are doing, environmental sciences. But environmental sciences is that if you want to study with us, we only got 2+2, which means that you need to go to UK no matter how. So 2 years over here and 2 years complete your course in the UK. All right.
It is the same like with the chemistry. I was like about to ask what 2+2. That means yeah, student need to go to UK to finish.
Yeah, they need to go to UK.
Right.
It's like chemistry also. Chemistry, because the thing is that the course is so specialized, and we are just about close to 20 years old. So we feel that this course, like chemistry and environmental sciences, which need more specialized professors to teach. In the UK, they have been there for 100 over years. So it would be better if they if they study and finish it off in the UK itself. Now, mathematics. This is also very, very popular in China. I'm not so sure in Indonesia, but a lot of people say that, oh, why should I become mathematician? Mathematics. What is the job prospect of mathematics, right? But let me tell you something. Don't be fooled by the name. Always remember that. Don't be fooled by the name. Look at the content itself and understand what actually you learn. And the most importantly is that what the skill set that you learn and you become useful in your whatever future career that you want to do. So mathematics on the left is called mathematics with applied mathematics. Now this is very interesting. Now applied mathematics is more of like if you give you one good example, you want to become a computational mathematician, where you design a model. Say give you example. Let's say in the mining industry, when you need to what they call engineer want to explode a certain mountain, all right, but at the same time probably somewhere around there got people living, some settlement. So the engineer need to ask a mathematician to calculate, if I explode this certain part, where the gravel or the things will fly. So this mathematician will come in and then they will calculate everything. They do a modeling in the computers. They will do put certain algorithms in mathematical algorithms, things like this. Then they will calculate. This is just one example. There are a lot of examples that you can do with applied mathematicians. There's another good example is you work with for instance like Google or Alibaba, and what they do is that there's a lot of data comes in, and they don't do what we call big data. What they do is that they do a different form of data analytics, where they can predict a certain thing from the trajectory of the data. Okay, so this is what the applied mathematics usually do. On the other hand, the statistic.
It was a great, sorry, Professor. It was a great explanation from you about this major, because a lot of the Indonesian students and even parents, they think, oh, if I study this major, I will be a mathematics teacher.
No, not necessary.
Yeah.
A lot of people also say that study mathematics, then become mathematics teacher. I can come in for, to be honest, if you want to become mathematics teacher, you don't even need to study undergraduate degree, right? I mean, the primary school and secondary school mathematics is to be honest with you, maybe I say this because I'm an engineer, but to be honest with you, it's not that difficult. All right, it's not that difficult. But these people, they go the different level of difficulty. Go to the partial differential equation. Those kind of very, very difficult mathematics. Even for me, sometimes in my research work, there are certain times when I see the model, I can't even understand how the model works. This is where I ask my colleagues in mathematics how this works. So he can actually see and he can say that, oh, this model, this is the equation will be the best, for you to simulate your model. Then I can do it. So I don't even need to build it in the real world. I can do it in the computer, and this mathematician come in and give me a certain equation that I can work on. All right. So these are the mathematicians. They're what they do. All right. Okay. So statistics is very interesting. Statistics is not just to count how many population, how many products that you have, how many export import that you have. Is more than that. If you heard about this, what we call this, one of the field that becoming more popular, we call actuarial science. Have you heard of this, Pak Joko?
Yes.
Yeah, actuarial science.
Actuaries.
Yeah, the actuaries. So the actuaries, what they do is that the actuaries, I usually joke, people say they don't understand what is the meaning of actuaries. So actuaries is like is the people with a crystal ball. So the crystal ball, if you know the myth, right? The crystal ball is that you can see the future. All right. So what the actuaries do is that they predict the future, not looking at your palm and say that your future you got 10 wife, you know, or 20 wife, or 20 children. No, it's not. They are very scientific. All right. So what I try to say is that the actuaries normally is used by insurance company to say that how long is your life. So they are the one is something like underwriter in the insurance company, that when you want to subscribe to insurance, then somebody will ask you a lot of questions, then actuaries will come up with a model. They say that, oh, I think your life can last to 80 years old. Okay, then we can insure you how much. All right. So these are the job of actuaries. All right. And then at the same time, also in the stock exchange, finance, also they also can need to predict. All right. So the actuaries, they are the one who do this. Now, how the actuaries do this? Definitely not by using a crystal ball, right? So they use scientific data, scientific methods. They use statistics to do this. So the statistician is very, very important, people. In fact, a country usually every country has one huge department. Every government have one huge department they call Department of Statistics. These are a lot of statisticians that they do, and they are the one who advise the department, the government, the president, you know, or in my country, the prime minister. They advise them, you know, for the next 5 years, you know, this will happen, and they will need to adjust their policy or the resources into a certain area that probably need improvement. So these are the statisticians. So this is what they're doing. Yeah, and there's a lot of other things also, including coding and cryptography. So coding and cryptography is basically encryption. So you don't want people to see your data, you want to encrypt it. So the statistician are the one who do this. Or if you want to break the code, so you want to break the code, not really hacker, but so yeah, basically hackers, they also more of a statistician, try to understand, you know, look at the pattern. And then they also not only look into data, they also look into the probability. All right, probability. Give you one good example of how this probability can work. I told you my field is in mobile and satellite communication. Basically, I'm a telecommunication engineer. So one of the problem in communication is what we call noise. Okay, noise. So you transmit from one side to another side. By this time, when you receive it, it's very noisy. It's very noisy because in between there's a lot of noise. So we need to find way to reduce the noise or mitigate the noise. In order to do that, the first thing that we need to do, we need to simulate in the computer. Now, noise, through statistics, we managed to find the property of the noise, then we simulate it and build the model in the computer, which is exactly the same as that in the environment. Why? Because it is very, very random. Right, it's very random. And how do we understand this random? We only can understand through statistics. Okay, so statisticians are the one who collect the data, look at the pattern, and then from the certain statistical formulas or methods or even algorithms, they come up with the model. They say that, okay, Dr. Kwong, this is the model. Use this equation. You should be able to emulate the actual environment in the noise, right? This is another example. Like I mentioned, I said, if I want to talk about examples, there's so many examples, right? I say that if you can make an appointment with Pak Joko and his colleague, probably he can make an appointment with Patrick, you know, and he can point to certain people like us. We can ask an expert to talk to you, you know, directly to customize, you know, exactly. You say that you want to become actuaries or the statistician, then we will tell you even more detail on this one. In fact, about a couple of years ago, I went to, I can't remember this one place. One student come to say that I want to become an astronaut. All right, I want to become astronaut. How? I said that yes, you can become an astronaut, but first thing you need to study is study engineering. Any field in the engineering first, all right? Then you become a specialist. Then you are useful when you're in the space, right? Because astronaut, you don't just go to the space and you just float and do nothing, right? You need to go to the space. You need to do some work, right? So most of the astronauts who go to the space are scientists, are engineers, right? Okay, so yeah, basically that is what we have. I will not talk about too much about masters or PhD. I understand that this is very much targeted for undergraduate student. But for this one, if you can read also, these are the list of the universities that we have partners, some exchange agreements. Okay, but this one changes over every year. All right. So, but the best is to check with us if you want to know more. Okay, so Pak Joko, so I basically okay already. I've done. For this particular PDF, I can send to Pak Joko, so he can. If you want to have a copy, you can most welcome, right, to get from Pak Joko to know more about us. If you see that each of these we have videos, right? Yeah, we have videos. Yeah, so it will be very useful for you to know more about us later. I also will encourage you to go to our website to visit, and inside our website, the link I will give to Pak Joko also. The website will have what we call a virtual tour to our labs. It's a 360. So you can like exploring in our building, in our lab, then you can have firsthand to see how our lab looks like, how advanced is our lab, things like that. I can give the link to Pak Joko. You can ask
Yes, please.
on where to go and to see if you want to visit us without flying here. Okay. So that's all. That's all. If you have a lot of questions, please feel free to ask, or you can write to me. But I really look forward to see all the Indonesians come here. We have a huge Indonesian community over here, and whenever I actually speak to a lot of Indonesians when I was in Jakarta or even in Surabaya.
Yes.
And even in this one place in Medan, okay.
Medan, yeah.
Yeah. So a lot of them, they ask me, how's the environment here? Should I learn Chinese or things like this? I say that you don't have to worry. The UNNC is like a bubble. Yep. The official English, everything here is English. But the good thing is here is like a transition for you if you want to learn Chinese. Over here. So you have a lot of friends. All of us are speaking English, and then at the same time you can learn Chinese. All right, maybe you speak with the food vendor over here, practice your Chinese over here. Yeah, things like this.
And also, I remember that the UNNC also got the Confucius Institute, right, for international students who want to study.
Yeah. The good thing about Confucius Institute is that they have they not only teach you, but they have exams. The HSK exam, where the exam, if you pass, it's just like IELTS or TOEFL.
Right.
It's the Chinese version of IELTS or TOEFL, right?
All right.
So if you reach a different level, let's say in the future you want to work in China, and you want the certain institute, they said that, we need more Chinese speaking people. When they said that, okay, I got this qualification. All right. So at the same time, while studying here, you can study also part-time, with a Confucius Institute. If I'm not mistaken, even pay also is not that much. I think most of the time it's free.
Okay.
Yeah, for you. But I think for this one, you need to ask more with Patrick.
Sure. Okay. All right. Yeah. What an excellent presentation from you, Professor Kwong.
Yeah.
Now, like all of us can understand more details about the Faculty of Science and Engineering, but especially the majors. That is very important. Okay, we wish we can recruit more international students to study at UNNC and especially at your faculty. Thank you very much for your support, Professor Kwong and Patrick.
Thank you so much. Always welcome.
Okay, well, graders, this is the end of today's info session. If you like this video, please press the like button and don't forget to subscribe to our channel. See you again in our next video. Bye-bye, everyone. Bye, Professor. Thank you so much. Bye, Patrick.
Thank you.